right, so you all know what the problem is. I give you as input an array of n numbers. Go ahead and think of them as distinct if you like. And of course, they're in an arbitrary order. And all I want you to do is rearrange them in increasing order. Okay? So same numbers, sorted in increasing order. All right. So merge sort, as you recall, it's a recursive algorithm. And so let me just first remind you of the high-level structure. So you recurse on each side of the array. Sorry. Oh, so I should say, every recursive algorithm has to have a base case. Here it's so trivial, I'm not even going to write it down. So if you're given an array of length 1, just return it. If it has a length bigger than 1, recursively sort the first half with another called a merge sort. Recursively sort the second half with another called a merge sort. And I'll just say this conceptually. We'll expand the pseudocode for this in a second. Once the two recursive calls do jobs, sort the first half of the array, sort the second half of the array, you now have two sorted subarrays. You need to merge them together into a sorted version of the entire input. Okay, so merge the two sublists into one. So kind of the cartoon picture you can have in mind so you start with some array. It conceptually gets split into two parts, which go to the recursive calls. And then, of course, each of these recursive calls will in turn fork off two recursive calls on further subarrays and so on. Okay? And eventually, once you bottom out of the base cases, you're going to start going back up the recursion. Okay? Now, as far as how you actually implement that recursion, it depends a little on the language. But, for example, in C, you could either pass up two pointers delineating the beginning and the end of the subarray that you're passing to the recursive subcall, or you could pass just one pointer to the beginning plus a number indicating the length subarray. So let's now go in a little bit more detail on this merge step. Okay. So pseudocode or merge step. Anyone remember? I don't want someone to suggest kind of lines of code, but just conceptually, once the two recursive calls come back, the left side sorted, the right side sorted. What do you do to combine them? What's a good way to combine them? Any suggestions?
Taking the left
How about a hand? Okay. Yeah. Go ahead.
Keep taking the left pair of the first the one together.
Right. So we'll lock down the two subarrays in tandem and keep figuring out which one has the current smallest element and copy that over. Okay. So just in one line of English, that's maybe a good summary statement. I'm going to explain a little bit more detail. Before I do that, I guess sort of a warning about 161. So even now, the pseudocode I'm going to write down isn't going to be super precise. It's not going to be in any one programming language. And as the course sort of proceeds, we're going to talk about algorithms at a higher and higher level of abstraction. Okay, so the pseudocode will get more and more sort of high level. Eventually, even pretty soon, we'll just start talking about algorithms in English. Okay, and that's really one skill that 161 should sort of teach you along the way, is it should allow you to think and reason about algorithms even when they're described at a very high level of abstraction, high level of generality. So my inductive hypothesis for 161 is that the courses that you have already taken to get here have given you the skill to take this high level discussion and translate it into a programming language of your choosing. Okay, that is my assumption of an ability that you already have. All right, so just up front, the algorithms are going to be fairly high level. But it's really in the course, so I'll be pretty detailed about this one. So let's have some notation. Let's C be the output array. So this is what we're going to return. Its length is going to be n. A is going to be the first sorted array. Length equals n over 2. And B is the second sorted array. Length n over 2. And as was suggested, basically what we're going to do is we're going to walk down the two already sorted subarrays in tandem, and after that we're going to populate the output array C in increasing order. Okay? So we're going to need indices to keep track of where we are in each of the two sorted subarrays. So there'll be one index I, there'll be another index J. This is what's walking down the two sorted subarrays. So we'll initialize those to 1. And then we're just going to have one main loop for k equal 1 to n. What do we do? So remember, we want to copy over the one which is smaller. Okay, so either the one in A is smaller or the one in B is smaller, whichever one's smaller we copy over. So if the one in A is the smaller one, then we set ck to be that. And we need to walk further down the A array. Otherwise, B has the smaller one. Oops. So that gets copied over into the C array. So sorry, these are semicolons, and these are J's. So, yeah, maybe I should actually use a comma here or something to make it more clear. Okay, so the point is you do a test to see which of the two arrays has the smaller element, and then in either case you do two operations. First of all, you copy over that element, and second of all, you increment the relevant index. Okay? And that's it. So any clarification questions about this pseudocode? One thing I should say, there are some n cases off one of the two sorted subarrays. I'm just ignoring them, okay, just for simplicity to keep it as clear as possible. So any handwriting questions or other questions about what this says? Look good? Yep.
Sorry, for 4k equals 1 plus 0.
Oh, sorry, yeah. 1 to n. Yeah, sorry. Good. Other questions? Yep.
Is there a way to do this without having a separate array for
So, yes, there are algorithms in place. Merge sort is not the choice for that, but we will talk about an in-place sorting algorithm in about 3 weeks. Other questions about what's on the board? Okay.